As we, well, part of the job is to get to the observatory, and that job is fairly easy. You just take a little ride up the side of a mountain. Start off at the bottom of the valley, and by the time we're done, I'll be up approximately 9,000 feet, which is not too shabby. This is not a bad mountain road. This is the road to Mt Lemmon. It's approximately, I would say, well, I could tell you exactly from the driveway of my home to the top of this mountain observatory. It's approximately 53 miles. And you'll notice as we go up this thing that the scenery changes from essentially Sonoran Desert, which was at the base, to various different biospheres, biomes, whatever the biological term is. Forgive my ignorance of such things. But as you can see, it looks more like what you would expect a mountain to look like. So notice it's not very green. It doesn't rain much in the desert, which is why it's a nice place to have an observatory. We move up the mountain a bit more, it gets a little bit greener. It's quite an interesting road, as you can see, and on occasion we meet people going in the opposite direction. But not to worry, our mission is to accomplish an observation tonight. The weather looks rather nice. We can take a look at the sky. We're going to swing around now. It's rather interesting driving with one hand on a road like this. And obviously you can see we're gaining altitude rather rapidly. There's some other mountain ranges over in the well, let's see, that'd be the background, I guess. So we're still on our way up, and more of that when we get a little bit closer to our destination. The university, by the way, has 2 observatories on this site. There is one at what is known as Mt. Okay. What I'm doing right now is centering the star on the TV monitor in the spectrographic slit. And at this point, I move the star's image east and west across the slit, since that's how it's oriented. And the result should be, hopefully enough, a nice, wide spectrum with the necessary absorption lines. And I'll find out if that's the case after I develop the film later on tonight. What you're looking at right now is the star's image between, or I should say right in the center of all those black marks that I actually taped, that I placed on the video monitor. I'm not in the control room at this time, I'm actually in the dome, as you saw earlier, but this is what's going on. I slide the image back and forth at various exposure times. The whole point of this experiment actually tonight is to calibrate the instrument with this particular telescope. It's time to move the telescope. It's time to move the telescope to a new location. This procedure is called slewing. And as I said, this is the largest telescope on Earth which is manually slewed. Or in other words, it uses the Armstrong method. Watch what I mean. That's how it's done. I'm setting the declination for the next star. And the computer computer is telling me where it is. The only difference with this and most modern telescope is that most modern telescopes require a push of a button to do what I'm doing right now. And then I guess another chapter of this video, at some time I'll show you how it's done on a very modern scope. I took the spectrograph off, and now we're looking directly at Mars. You can see the polar cap, I believe. This monitor isn't very clear, but that's what Mars looks like through a 60-inch telescope using this video camera as the actual detector. Isn't that neat? I think so. I wonder what that looks like. At this point, I have to close down. The humidity reached 96%. As a result of that, I had to terminate my observing run. I got about 4.5 hours worth of observations and hopefully some good data. I'll find out as soon as I develop the film. Well, so that's what it's like. We'll be ready to go. We're out of the gate, or through the gate. We're heading up toward the observatory. What I usually do is just pull up to the facility first and drop off the equipment, and then later on come back down. If this sort of looks like an old abandoned military area, it indeed was at one time. There's the 40-inch dome, and the 60-inch is right there. 60-inch telescope, and we're right on top of, this is as high as you can get in and around Tucson. So we'll just pull up here and unload the equipment. Well, here's what it looks like standing on top of a mountain 9,000 feet above sea level. In a minute we'll go inside the dome. Notice you can have fights with the clouds here on a one-to-one basis. It's rather hazy out there today. Well, in that area, somewhere, is where I live. And the university and the college are off in that direction. When the sun goes down, we'll take a look at the city lights and how they don't affect what we do up here. We're sort of entering, yeah, we are entering at this point. And there's the telescope that we'll be using tonight. This is the world's largest hand-guided or hand-positioned telescope. It's a NASA facility. The university uses it and maintains it. And that was one of the doors that shut. Caught me off guard. This telescope, as you can see, in terms of size in relation to my own size, the mirror is there, 60 inches across. In a few minutes, what I'll do is bolt the spectrograph right here, tailpiece. And once that's done, I'll be ready to observe when the sun goes down. So it should be rather exciting. I'm looking for a clear night, and everything should work out rather nicely. And then again, I brought a book in case it clouds over. So, it's not very complicated, the device, it's just very big. Into the control room area. Oh, look at this. There's the kitchen. like someone has anticipated my arrival. This is the computer that controls the telescope, which when we're ready will be active and everything will be functioning just fine. Yeah, now you have the exact time when I recorded this. There's a red light. Let's get some white lights on. And this is called the lounge. And that proves to be handy when it gets pretty tiring and you need to rest a bit. Have a little stove, make some hot chocolate, popcorn, or anything else that's convenient to eat. And this is not the dormitory. We usually don't sleep here. This is a rather interesting looking piece of equipment. I have no idea what this is. I'm seeing it for the first time. Looks like someone is going to be doing some interesting work here shortly. So, let's see what else is at an observatory. Very important room. And there's the outside. So, all the comforts of home, including a bottle of oxygen. Remember, we are over 9,000 feet in altitude, and some people really are sensitive to that. So, time to get to work. Let's see, what else can I show you here? Little shop areas, various instrumentation for a number of interesting things, a little workbench, and some neat garbage. It's very important when you need to find just the right tool to do the job, or a piece of wire tape to hold things up. And then finally, we're back out to the observing chamber. And once again, the telescope. Well, this time I'm going to get ready to mount the instrument. This is a spectrograph. Rather small little device, but powerful, which will be put on the telescope. Activate the main power of this one. And it should be on. I think I got to put off due to a power failure while this thing is rising. I'll just turn it up a little bit more. Not bad at all. Okay. Luckily, this isn't very heavy, but I prefer to do things in a deliberate way so I can repeat everything I do. It's a problem. This is not a benign environment, although it may look like it is. And we'll just bring this up a little closer. Okay, we're getting much closer now, and in a moment I'll just raise this in place. We'll be all set. This This is when you hope you have the right bolts. It is the right one. Essentially, that's it. The bigger the instrument, takes a little bit longer, but this is the procedure that's followed. And we're ready to go, almost. Thing on the spectrograph is that which will collect the spectrum. You'll notice it looks awfully familiar. It looks very much like a 35mm camera back, because that's exactly what it is. So the detector for this scheme will be 35mm film. An entire spectrum from approximately 3,500 to 7,000 angstroms is going to fit across the width of a 35mm plate. That's approximately a resolution of 72 angstroms per millimeter. And hopefully, when I'm through calibrating the instrument tonight, which is the purpose, we'll have some interesting data and be able to do some serious work with this device. Well, take a look at what the rest of this telescope is like while we're up close. I want you to notice that right there is the secondary mirror. And you can see the reflection of the primary mirror's covering in that. There's the spider that holds this. It's a rather impressive instrument. Right now I believe it's in the F13 mode. This is the TV camera, the TV acquisition guiding system, and that is part of the finder scope, which is a 6-inch refractor. Okay. And this is an extremely wide field finder, which is not unlike some surplus military hardware you've probably seen. And this is the eyepiece end of the primary finder scope. Controls the mirror covers, and why don't we open the mirror covers so you can see what's going on with that. You can see the mirrors opening. Here it goes. Second one now. It's opening. Isn't this exciting? Whoops. And you see, now we're ready to look at the sky. Now before we can hope to look at the sky, we have to open up the dome. That'll do that. Of course, when I continually do this later on this evening, the sun hasn't gone down yet, so we don't want the dome area to heat up any more than it has to. So when it's time, that will be open and we'll be ready to go. It's a rather interesting dome in that that was a tripod that fell, but such is life. The dome is rather big. You notice from this vantage point, it sort of looks like a silo that you probably have been familiar with in your observations of silos hanging around where they store grain. We're in the dormitory area right now in the kitchen, and of course, as we all know, it's very important to eat. You're an astronomer as well. So tonight I'm going to have some glazed breast chicken, which is mighty tasty. And whatever else they can put in this package. It fits in here, notice space age food. What else for an astronomer? This is the time of the day that we wait for, when the sun sets. And as you can see, it is rather humid today, but if that doesn't change, we may not open the dome at all tonight. Hopefully, that will change. too high, then dew would form on all of the equipment, and if that happens, then the equipment gets rather soggy. It could cause all sorts of electrical problems. But there may be some hope. It looks like a bit of clearing in that, which is the west, of course, and some high thin clouds, some mean looking rascals to the south and the east. So we'll just have to wait and see if this is going to turn out okay for us. Day turning into night, that valley would be rather crystal clear, and you can see there's a great deal of humidity to be had. Well, we'll see. That's a rather pretty sight. It is 85%, up from 80% just a half hour ago. If that continues to climb, even though the sky looks clear, we're probably not going to be able to observe tonight, which is unfortunate. This time I'm going to open the bottom portion of the slit in anticipation of an observation tonight. Right now is the planet Mars, and the sun still hasn't set completely. I don't know if you can make it out, but there are some really ominous looking fluffy type clouds that aren't very significant but indicating high humidity. Now is the star of which its spectrum, well, that's the star whose spectrum I'm going to take. So that